We want to convert the point 2 comma 3 pi divided by 4 comma 2 pi divided by 3, which is given in spherical coordinates, to Cartesian coordinates or rectangular coordinates. So we want to find x comma y comma z, given that we know rho equals 2, theta equals 3 pi divided by 4, and phi equals 2 pi divided by 3. So we'll find the Cartesian coordinates using our formulas provided here. So x is equal to rho times sine phi times cosine theta, which should be 2 times sine 2 pi divided by 3 times cosine 3 pi divided by 4. And then y is equal to rho times sine phi times sine theta, which would be 2 times sine 2 pi divided by 3 times sine 3 pi divided by 4. And finally, z is equal to rho times cosine phi, which is 2 times cosine 2 pi divided by 3. And now to find these trig function values, we can use a unit circle or reference triangles. Let's first use reference triangles, and then we'll check the values on the unit circle. So we'll sketch 2 pi divided by 3 and 3 pi divided by 4 in standard position to sketch the reference triangles. So 2 pi divided by 3 is also equal to 120 degrees. So the initial side would be here, the terminal side would be approximately here, where we'd have a reference angle of pi divided by 3 radians, or 60 degrees. So the reference triangle would look something like this, where we have a 30, 60, 90 reference triangle. So we can label the three sides 1, 2, square root 3, but because we're in the second quadrant where x is negative, this would be negative 1. So we can use this reference triangle to find the trig function values for 2 pi divided by 3 radians. And now we'll sketch 3 pi divided by 4 radians, which is also equal to 135 degrees. So the initial side would be here, the terminal side would be in the second quadrant, here, where now the reference angle would be pi divided by 4 radians, or 45 degrees. So the reference triangle would look like this. And now because we have a 45, 45, 90 reference triangle, we can label the three sides 1, 1, square root 2. But again, because we're in the second quadrant, this leg would be negative 1. So this would be the reference triangle for 3 pi divided by 4 radians. So now we can find our trig function values. For x, we have 2 times sine 2 pi divided by 3 would be equal to the ratio of the opposite side to the hypotenuse, which is square root 3 divided by 2. And then for cosine 3 pi divided by 4, that would be equal to the ratio of the adjacent side to the hypotenuse, which should be negative 1 divided by square root 2. But if we rationalize this, we should recognize this would be negative square root 2 divided by 2. Let's go ahead and use the cosine function value in this form. So we have negative square root 2 divided by 2. Simplifying before we multiply, 2 divided by 2 simplifies to 1. So x is equal to negative square root 6 divided by 2. And now for y, we have 2 times, we already know sine 2 pi divided by 3 is equal to square root 3 divided by 2. And now sine 3 pi divided by 4 is equal to the ratio of the opposite side of the hypotenuse, which would be positive 1 divided by square root 2. Well, we know 1 divided by square root 2 is also equal to square root 2 divided by 2. So let's go ahead and use square root 2 divided by 2. And notice here, again, this simplifies. So our product is positive square root 6 divided by 2. And then finally for z, we have 2 times cosine 2 pi divided by 3, which would be 2 times cosine 2 pi divided by 3 is equal to the ratio of the adjacent side to the hypotenuse, which would be negative 1 divided by 2, or negative 1/2. So notice here, the z-coordinate is just negative 1. So the Cartesian coordinates are negative square root 6 divided by 2, comma, positive square root 6 divided by 2, comma, negative 1. And before we go, we did say we were going to verify our trig function values on the unit circle. Let's go ahead and do that. Here's the angle 2 pi divided by 3, and here's the angle 3 pi divided by 4. So the x-coordinates give us the cosine function values, and the y-coordinates give us the sine function values, which does verify we found our trig function values correctly. I hope you found this helpful.